This is part 2 of section 1.2. Last time we looked at the ruler postulate. If you want to find out how long a segment is, all you're going to do is take their coordinates and subtract them. And you're going to take the absolute value of that, so your distance is positive. That's what we did last time. This time we're going to get some practice using that ruler postulate. Okay, so the first thing you might see there is your number line. There's a whole bunch of points there that have names, and there's some points there that don't have names. It's okay. Underneath, there's a coordinate for those points. Some of the points don't have coordinates there, but if you can quickly look at that number line and determine the scale that they're using, you could probably fill the coordinates in yourself. So it's probably not a bad idea to maybe pause the video and on your notes, maybe write those coordinates in. Okay, number 2 asks, how long is segment FH? So on this number line, there's obviously many segments. We want to know how long is it from point F to point H. That's the length of segment FH. Now, if you use the ruler postulate, all you're going to do is subtract the coordinates and take the absolute value. So you might need a calculator here too. If you don't have one, maybe pause this, get one. Okay, so point F, hopefully you realize that's at the coordinate 3, and point H lives at the coordinate 9. Subtract them. 9 minus 3 gives you 6, and take the absolute value. How long is segment FH? It's 6 units. Now, if you would have subtracted them the other way and you would have done 3 minus 9, you would have gotten -6. But when you take the absolute value, remember that changes it to positive, always. Absolute value always gives you a positive answer. Lengths of segments are always positive. Now, if you didn't want to use the ruler postulate, for example, this is a very simple number line here. You could have just counted the 6 spaces. Put your finger on point F and count the jumps that you make to get to point H. There should be 6 of them. You can do it that way too. You can count as well. The ruler postulate really is designed for when you have bigger numbers or fractions perhaps that maybe you're not comfortable counting by certain numbers. Okay, but counting on a number line is usually pretty easy. We're not going to do a whole lot of complicated examples. Number 3, they ask you to find, and then it has an F and an H. We need to know how to read that. That's really important. That's another thing we did in the previous video. What does it mean when you have 2 capital letters with nothing over top of it or in front of it? That's asking you for a distance. How long is segment FH? It's asking you the same question that number 2 did. How far is it from point F to point H? That's another way to say the same thing. So your answer here is also 6. Okay, so number 3 is a quick way of asking you the same thing number 2 asked you. Number 4, don't forget, what does that say? Find the distance from C to G. Look at point C. It lives at -5. Look at point G. It lives at +6. You can subtract 6 minus -5. That'll give you 11. You could have also done it the other way, take the absolute value. Could have also counted the spaces. Number 4, the answer is 11. Okay, number 5, they kind of changed the wording, but they're asking you to do the same basic operation and calculation here. How far is it from point A to point D? That's how you read that statement. A lives at -9. D lives at -2. How far is it from -9 to -2? You can count, you can subtract and take the absolute value. Totally up to you. -9 minus a -2. That's the math that you're doing. That's like -9 plus 2. That gives you -7. But you take the absolute value. How far is it from point A to point D? It's 7. Number 6. Again, make sure you're reading this correctly. Find the distance from A to D. That's the same thing as number 5 again, just different way of saying it. Okay, so the answer there is 7 as well. It's important that you see different ways of asking the same question. Two more examples here. We're going to do number 7 and we're going to do number 8. And notice how these are parts of a ruler. Some of you probably aren't super familiar with using a ruler. Some of you might have a decent understanding of it. If you're not sure, it's okay. It's the same thing as the ruler postulate. That's why the ruler postulate is called that, because it kind of explains to you how to measure. Okay, so for number 7, notice the length they're asking you to find is up top there. How far is it from A to B? You could count if you wanted to. You could subtract if you want to. We know you're not probably a huge fan of subtracting fractions, but I think we can handle it. This is just a section of a ruler. So if you look at that section, how many spaces do we have from the start of the ruler to the end of that portion? You can pause this and count if you want. Okay, you should have counted that there are 16 spaces. So each of these little spaces is a 16th of an inch. So if you want to fill in the blanks for the coordinates there, you could. That first little blank there would be 1/16. The second little mark there would be 2/16. But we know that 2/16 reduces to 1/8. That's why the 1/8 is there. And then you keep counting. So you got 1/16, 2/16. That third little line is 3/16. The fourth one is 4/16. 4/16 reduces to 1/4. The one after that is 5/16, so on and so forth. So if you're just counting the distance from A to B, we know each little space is a 16th of an inch. Let's count together from A to B. I see one little space, 2 spaces, 3 spaces, 4 spaces, 5 spaces, 6 spaces from A to B. That means it's 6/16. Now, both of those numbers are even, so you can reduce that fraction, 6/16. That's the same thing as 3/8. Now, we did that by counting. You could also use the ruler postulate. Let's take our coordinates and subtract them. Notice where point B is. It lives at 5/8. We're going to take that number and we're going to subtract the coordinate for point A, 1/4. What is 5/8 minus 1/4? At this point, if I was capable, I would show you, I would write this out in front of you so you could see it. Not really have those tools at the moment, but hopefully we're working on it. You could type this into your calculator. 5/8 as a fraction, that's 5 divided by 8. Subtract 1 divided by 4. It's going to give you the same answer of 3/8. Because remember, 1/4 is really 2/8. What is 5/8 minus 2/8? It's 3/8. Okay, that's how we measure here in the States. We measure in inches. 16 of these little spaces make an inch. Well, the metric system, we don't typically use that. They use that overseas. The metric system is probably a little bit simpler because everything is in base 10. For example, if you look at the centimeter side of this ruler, at the beginning of the ruler to the 1 centimeter mark, there are 10 little spaces. From the 1 centimeter mark to the 2 centimeter mark, there's another 10 spaces. So each of these little spaces is a tenth. On the inches side, it was each a 16th. Okay, so that's a 16th is a little more complicated than a 10th. So if you want to fill in your coordinates, you can do that. That first little space, you could put 1 divided by 10 if you want, or you could put 0.1 because that's how you read 1/10, 0.1. So the second little line would be 0.2, the third line would be 0.3, fourth line would be 0.4, so on and so forth. Where does point C live? Lives at 0.5 or half of a centimeter. Let's find where point D lives. Point D is a little bit past 2 centimeters. How many little spaces passed? 2 spaces passed. So point D lives at 2.2, if that makes sense. So we're going to use the ruler postulate. We're going to take 2.2 and we're going to subtract 0.5. And again, you can type this into your calculator if you need to. What is 2.2 minus 0.5? Okay, that'll be the length of segment CD, which is what we're doing there in number 8. They ask you to find the length of segment CD. I don't think I really mentioned that. Okay, 1.7 centimeters is what you should get. That's using the ruler postulate and subtracting the coordinates. Now, you could count if you wanted to also. If you count the spaces between point C and point D, you better get 17 spaces. That's 17 tenths, which is the same thing as 1.7. That's what we just figured out before. Okay, so if you've ever been confused when you use a ruler, it's really as simple as counting. And if you want lengths of something, again, all you're doing is taking those coordinates and subtracting. And you can do it on a ruler too. It's really not that bad. Again, if you have any questions, don't be afraid to reach out.